Radio, kia ora koutou. I thought we'd have a wee look at these two practice tasks that you guys have been given. So these were written by Miss Seymour, and they're really good. We noticed that we're not talking about any circle stuff with these. They're just dealing with triangles and just a couple of real life questions. These are the achieve skills that we're practicing here. Okay, so first of all, we've got Tully. I made them about you guys. Tully designing his new tramping hut for Doc. And so this is the roof of it. So we've got this diagram. So here are my worked answers. For the first one, I've already written some answers. For the second one, I'll go through them on this video. So the first question asked what the total length of timber is to build the frame of BE. So in other words, we want that length of wood between point B and point E. Okay, so BE is the name for that line there between point B and point E. So I've called that X with a green X there. So we have to work out which triangle that belongs to. Does it belong to that triangle on the right here, or does it belong to this one here on the left? Which one is it going to work best with? We could use either of the triangles. So let's have a look. If we look at this triangle here on the right, we see, okay, has it got enough information to use the sine rule, or has it got enough information to use the cosine rule? So at the moment we know a length and we know an angle, and we want to know another length. That's not enough information for the sine rule, is it? Because we need two angles and a side and another side. It's not enough for the cosine rule because we need two sides and an angle to find the other side. So let's have a look at this other triangle. Let's look at the one on the left hand side and see if that's got enough information. So this has given us 4 meters, 6 meters, and then this angle here of 75. Already we can tell that's got more information in it, so we can probably use this one. So we're going to use sine or cosine rule. So let's have a look. Sine rule, it's two angles and two sides that we're talking about. Cosine rule, we've got, that's whenever we're talking about three sides. And this will work, won't it? Because we know two sides and we want to know. So yeah, we could use the cosine rule for that left-hand side, couldn't we? Okay, so you write out the cosine rule. A squared equals B squared plus C squared minus 2bc cos A. We've got it there. Okay, so step number 1, we're going to draw a diagram. You'll see that in here it says diagram if you need it. You should always draw yourself a little diagram. And all that means is let's draw the triangle that you're just dealing with. Like, get rid of all that other crap. We don't actually need it. Let's just deal with the triangle that we're talking about. So in this case, it's just the one with A, B, and E on the vertices there. So we've got 4 meters, we've got our 75 degrees and our 6 meters and our X. Okay, and away we go. So you've got your cos rule there. You're putting in your 4, your 6, and your 75. Okay, so this is just like you practiced in the book in the cosine chapter. Yeah, and then remembering to do the square root. So you end up with 39. And just remember you've got to do that square root, don't you, to get A. So beautiful. Remember, once you've worked out how long it is, that you need to relate it to the actual question and the real life application that it's about. So we were trying to find the length of that piece of wood. So we need to now say a sentence about that. So here I've written, so Tully would need 6.2 meters of timber for the frame for BE. Okay, sweet. So I hope that makes sense. All right, question 2 for this. Find the value of angle E. So angle E is down here. It's this one that I've done here in red, angle E here. I'm just going to rub some of this other stuff out just to get it all out of the way. All right, angle E there. Let's first of all just write in, because we've now worked out something and we can add that to our diagram. So can we put in that 6.29 meters where it belongs here? 6.29 meters along there for BE. All right. So yeah, we want to find angle E. So let's have a look. Looking at both of these, oh no, not both of these triangles, because it's actually only in this triangle here, isn't it? So this is the triangle that we're going to have to deal with. So we have a wee look, sine rule or cosine rule. So if it was a cosine rule question, we'd need two sides with an angle in the middle, wouldn't we, that we're dealing with. this isn't one of those by the looks of it. It looks like it's an angle opposite a side and an angle opposite a side. So that's our sine rule, our lovely little sine rule. So we're going to use our sine rule. Remember, this is the one where our capital letters, our angles go on the top. So they're the numerators of these fractions. So it's this version of the rule here. Sine A over A equals sine B over B. So we've drawn our diagram. Notice on the left-hand side, I've just drawn that triangle again, okay, just all by itself without all the other stuff to get me confused, okay? So I've just written in the bits we know, the 72 degrees, the 4 meters, and the 6.29 meters. Sorry, my drawing's really rough. Okay, substitute all the bits and pieces in. So we've got our E, in this case, is what the angle that we want to find is called. He's opposite the 4 meters. And then we've got our 72 degrees, and he's opposite the 6.29 meters. So plop them all in, work out what sine 72 divided by 6.29 is in your calculator. And then remember our next step. So we're going to now times that by 4, and then do inverse sine. So that's shift sine of your answer. And you'll end up with 37.21 degrees. Remember that you're answering the question. It asked you, what is that angle? So just write it in a little sentence at the bottom. Okay, remember to put your degree sign and that you've rounded it, so in this case to 2 decimal places. All right, so lovely. That was task number 1. Task number 2, Lacey's alpaca farm. So she's got this huge alpaca farm. Good on you, Lacey. A small section of it is shown here. All right. So it talks here about produce a report by calculating the length of the paper road running through the land. This is where Lacey will put her flying fox for the alpacas. Okay, so Lacey has decided that life needs to be a bit more interesting for the alpacas, so she's setting up a flying fox. A paper road, guys, is like a little, it looks like a road on a map, but it's often sort of dotty lines like they've got here, and it's sort of where maybe one day the council might put a road there, but there isn't one there at the moment. That's sort of what it is. It's not made of paper. Calculate the total distance outside is the next question. So in other words, the perimeter of this quadrilateral that we've got here, this 4-sided shape, and calculate the size of the 4 angles that are not in the diagram. So at the moment, we've got 2 angles that are in this diagram. We've got 80 degrees and we've got 72 degrees. We need to figure out what those other 4 angles are as well. Notice that it says produce a report. That's because these are just really beginning questions, and when we do our other practice assessments and then our actual assessment, there'll be some sort of real life situation, like where Lacey's wondering whether to sell this section of the farm, or maybe Lacey's thinking about whether she can afford to build a new fence around the whole outside. And so we'll need to do certain things and then relate that back to the initial problem, whatever it is. Okay, but we're not quite delving into that yet. We'll just focus on the skills. So question 1, what is the total length of that road, that paper road PR? So PR, that's the line from P to R, or from R to P, it doesn't really matter. So let's work that out. So let's draw a diagram. We want to know PR, so it's this guy here, isn't it? We'll call him X. Just like before, he's actually part of 2 different triangles here, eh? We've got this triangle on the left here, and then we've got this triangle on the right, and he's a length for both of them. So we just need to decide which triangle has the most information in it that we want to use to do this. Hopefully you can see from here that yellow triangle looks like it's got the most information. It's got 2 sides and an angle, whereas the other one only has 1 side and 1 angle. So that left-hand one, let's use that. What have we got? So we've got 2 lengths. We want to know a 3rd length, and we've got 1 angle involved. Those 2 lengths that we know, notice that they've got the angle in between them there. Looks really familiar. So that's the cosine rule, eh? So brilliant. We know it's cosine rule. A squared equals B squared plus C squared minus 2BC cos A. Let's draw a little diagram. We've got R down here, S, 80. Yours would not be as messy as this though, guys, would it? We've got A, P, and R. I've got a new computer and it's all kind of slippery to write on. I'm not used to it yet. All right, so you're just going to go through and use the cos rule to figure out A. I'll quickly do it now. What have we got? 285 squared plus 310 squared minus 2 times 285 times 310 times cos of 80. Grab a calculator. Oh my goodness, and it's hard to see because it's kind of dark right now. Squared plus 310 squared minus 2 times 285 times 310 times cos of 80. And I'm getting 146,641.367. Of course, that's way too big, isn't it? We need to make sure we square root it. Okay, so square root, answer button. Okay, we end up with 382.94. That sounds like a way more reasonable answer, doesn't it? 382 meters? Sounds pretty good. All right, so that is the length of the paper road, and we would then write a sentence, of course. So the length of the paper road and remember that they called it in the question, what is it? PR. I said that in the original one, is 383 meters long. Notice there that because it's such a large number, I figured I may as well, and it's really close to 383, that I may as well just round it up to 383. You could leave it at 382.94, absolutely fine. I'll just put over here though as well that I did round that to 2 decimal places. There. All right, so let's have a look at part 2. It asks us to calculate the total distance outside. So in other words, what's that distance all the way outside? What's the perimeter of that quadrilateral? So let's write on our diagram that length that we've just found out. So 383 meters. 383 meters. Okay, so what do we need to find out to work out the perimeter around that whole thing? We're going to need the 285 plus the 310 plus the 280 plus this side here, PQ. We don't know how long line PQ is yet. So that's the guy we need to find out, isn't it? All right, so he's part of that right-hand triangle, PQ. At the moment, with that right-hand triangle, we've got 280 meters, and I'm just going to draw it off to the side here so it doesn't look quite so messy. PQR. We've got 72 degrees down here, 280 meters, 383 meters, and we want to know that one there. All right, cool. Looking at that, 2 sides, they've got an angle in between them. Okay, we want to find a third side. It's cosine rule again, isn't it? So jump on in with the cosine rule. You know what to do. Diagram. I'll just point to up there. We've written the rule out just above. You would write that again, guys, but I'm just going to do it a bit faster. And then let's chuck in our numbers. So what have we got? 383 squared plus 280 squared. Minus 2 times 383 times 280 times cos of, what is it, 72? Okay, so x squared equals, all right, so 383 squared plus 280 squared. Just take care with your calculator, guys, when you're using it. You might want to put brackets around this whole second part here. It will use BEDMAS for you, but just got to be really careful, because if you accidentally push equals at the wrong time, you'll end up with it all jiggering up for you. Remember, that's also why we want to check that our answers make sense at the end. All right, I'm getting 158,811.035. I need to, of course, square root that because x squared is that. So square root of answer, and I'm getting 398.51. It's a length, so we're talking about meters, and we've rounded it to 2 decimal places. That is telling us, of course, what that fourth side of our diagram is. The question, however, was calculate the total distance around the outside. So this could be telling Lacey how many metres of fencing wire she needs to order.